Welcome to the Wine Math series. My name is Erin Norton, and in this video we'll be going through all things relating to units when it comes to wine. Units are really important. You need to understand the meaning behind units and the context behind units, and also how to convert between certain units. So if you would like to skip ahead to different parts of this video, there is timestamps with the descriptions in the video down in the video description. So feel free to jump ahead and find the spot in the video that is suited to what you want to know. All right, let's get started. So units are really important when they are associated with a number because they give a number meaning, okay? Meaning or context, and they can help winemakers make decisions if you know and if you're using the correct units. So, for example, if we were talking about temperature, okay, and if I said to somebody, oh, it's 30 degrees out today. Well, depending on what unit you are talking in, the number, the temperature outside could be very, very different. So, for example, if I'm talking about degrees Celsius, okay, that's a hot summer day. Okay, that's a warm summer day. And in terms of wine temperature, that'd be probably what you reach for maybe some of your red wine fermentations. However, on the flip side, if the unit I was talking about is degrees Fahrenheit, well, that's pretty cold. Okay, 30 degrees is below freezing, and that's a pretty cold day. And in terms of wine, might be where you're doing some of your cold stabilizations. Okay, so very, very different. But it's the exact same number, okay? So some units that we use in terms of wine that are important include mass and volume and then concentration. And so some of the mass units we use in terms of metric units, we talk about milligrams or grams or kilograms, okay? And if we are talking about US standard units, you might be familiar with ounces or pounds or tons. Tons can be in metric units as well. So make sure you know which one you are dealing with. Volume, a lot of time we're talking in milliliters or liters or hectoliters, which are important in wine. And on the flip side, for US standard units, a lot of times we might be talking in quarts. Maybe not so often in quarts, but gallons for sure is really important. And then concentration. There's lots of different ways that we can express concentration, and we will talk in more detail about what concentration means. But some of the units you may be familiar with, there's grams per liter, pounds per gallon. Okay, so those are mass per volume units. There's ppm, okay, parts per million. And then there's also things like percent volume by volume. That is a concentration unit, okay, that we use to express the amount of alcohol in a wine. And then there's also mixed units between metric and US standard units like grams per gallon. Okay, so let's jump into some actual units and conversions, and we'll start with metric conversions because they tend to be a little more straightforward. And there is a nice little chart like this that we can use, and we don't need to memorize conversion factors or look up conversion factors. And so metric conversions are based on a scale that is all related and related by powers of 3, okay, 10 to the 3, and that we can interconvert these. The one that I do want to point out that's missing on this chart on the left-hand side of the screen here is, where is hecto? Okay, so hecto would be right in here. Okay, and we give it the letter H. So we can talk about hectoliters, and this would be 10 to the 2 greater than the base. Okay, and so when you are taking a number and you want to convert between milligrams, let's say, to kilograms, you're going to be dividing that number. Okay, when you say want to go from kilograms to milligrams, you are going to be multiplying that number. Okay, so just something to keep in mind of how to move. Now, the one thing I want to point out is the number doesn't change. The amount doesn't actually change. You're just trying to change how you talk about that number. And we'll do a couple of examples down here. But first, I just want to point out how you would go from milligrams to grams or grams to kilograms quickly. So these are little diagrams that you might want to copy out and keep somewhere on a bulletin board that's handy. So if we wanted to go from milligrams to grams, okay, the number's not going to change, but the unit is going to get bigger, but so therefore the number needs to get smaller. So we're actually going to divide by 1,000, okay? And same thing when we go from grams to kilograms. We're going to divide by 1,000. Okay, and you can see that if we were going from milligrams here, okay, up to kilograms, okay, we are going to be dividing. So if we go backwards, kilograms to grams, we're going to multiply that now by 1,000. And grams to milligrams, multiply by 1,000. And you can go in one step from milligrams to kilograms. I recommend going in 2 steps just to make sure that that you are, you've got enough zeros in there basically when you're doing the calculation. Same thing with volume. So milliliters to liters, we are going to divide that by 1,000. Divide the number by 1,000. Okay. And then liters to hectoliters this time, we're going to divide by 100. Hectoliters to liters, we're going to multiply by 100. Okay, and then liters to milliliters, we're going to multiply by 1,000. Okay, so if I had 5 grams, what would it be in milligrams or kilograms? Okay, so let's set up this calculation. So I have 5 grams. I like to start with the value I'm given. And then I know I want to get to milligrams. Okay, and I'm going to need to put grams on the bottom here so that the 2 units can cancel out. So I need to figure out what is this conversion factor. Well, I know that in 1 gram, okay, I have 1,000 milligrams. So 1 gram is the exact same as 1,000 milligrams, okay? And so I am going to cancel out the unit, but never ever cancel the number. And when I compute this, I get 5,000 milligrams. Okay, and so what you can see up here from our little diagram, when we have grams and we want to go to milligrams, we multiply by 1,000. And that's exactly what we did here. And this is, I just want to show you though, the conversion factor of how we actually change that unit from one into another. So let's go the other way and do kilograms. So we're going to start with our 5 grams. And this time we want to have kilograms as our final unit. And again, we need to put grams on the bottom so that we can cancel out that unit. So we know that 1 kilogram equals 1,000 grams. Okay? And so when we cancel out our units, but not the numbers, okay, and we compute this out, we will get 0.005 kilograms. Okay, so we essentially divided 5 by 1,000. And so when we want to go from grams, okay, again, grams, to kilograms, we are dividing by 1,000. And that's exactly what we did there. Okay, so let's do one more example. And we're going to look at if we have 600 liters, how many hectoliters is that? And the reason I want to do this example is it's a little bit different than the previous examples with milligrams and kilograms. To convert liters to milliliters is the exact same thing. Okay, you've just got a different unit that you're using. It's a volume unit, liters. Okay, so to set this one up, we have 600 liters. So the amount of hectoliters we've got 600 liters. And we know we want to end up with hectoliters, okay? And we're going to have liters on the bottom. And this is so that the two can cancel out. And we know that 1 hectoliter, okay, equals 100 liters, okay? So again, we cancel out the liters. We're left with hectoliters afterwards. We compute this out. 600 divided by 1,000 gives you 6 hectoliters. Okay? So you might become more familiar with it, you know, the more you use it. And usually the way I always think about it is just take off 2 zeros. The last 2 zeros of your liters, and that'll give you hectoliters, just in case that's a quick little tip for you. Okay, let's get into concentration. So wine in general is a solution, okay? And that's something that you need to remember. It is an aqueous solution. So I'm just going to put this here, meaning that it's based in water. The majority of wine is water, okay? Usually, you know, we talk about 80 to 85% of the solution is water. So the solvent is the majority component, okay, in any solution. And in this case, it's water. Okay, it doesn't matter when it's juice, it's an aqueous solution, it's a water solution. When it's wine, it's still a water solution, okay? A solute is anything dissolved, okay, in the solution, in the solvent. Anything dissolved in the solvent. There are lots of solutes in wine, okay? Some of the common ones, obviously, that we talk about: sugar, acids, sulfur dioxide that we put in wine, or alcohol. And there's lots of aroma compounds, there's lots of color compounds, there's lots and lots and lots of different types of solutes, okay? And so when we're talking about each of these, we've come to this place where we have a convention to talk about each of these with various units. So when we're talking about sugar, a lot of the times you might see sugar listed in grams per liter. You might also see percent, and this is typically, just so you understand, a weight per weight percentage. Okay? And we will talk about that in just a second. Acid, we usually talk about grams per liter. Okay? And sulfur dioxide, we also talk about this in a unit that is known as parts per million. And I'll get into that in a little bit more detail as well. And then lastly, alcohol. This is actually where we use percent volume by volume. Okay, so most of these are based on the top 3, sugar, acids, and sulfur dioxide, are based on a weight per volume, or a mass per volume measurement, whereas alcohol is a volume per volume measurement. Well, and sugar, we could talk about it in a weight per weight, but because it's water and the weight and the volume of water have a special relationship, it's the same. It's essentially the same thing. Okay, so I do want to explain this percent weight by weight and percent volume by volume just in a little bit more detail. So let's use an example to talk about sugar. So let's say I have 10% sugar, okay, weight by weight. What is it in grams per liter? Okay, how do we interconvert? And this will help us understand what weight per weight actually means. So weight per weight, what that means is that you have 10 grams of sugar in 100 grams of solution. Okay? Now, we also know in a water solution that 1 liter of solution, okay, so I'm just going to write aqueous solution. 1 liter of solution equals 1 kilogram, okay, which equals 1,000 grams. Okay, we've talked about that already a little bit in this video. So 10% of 1,000 grams is 100 grams. Therefore, a 10% solution equals 100 grams per liter. Okay? So that's how, so to interconvert between percent and grams per liter, the easiest thing to do here is to multiply by 10. Okay? So that's the quick way of doing that. But this is just an example or explaining to you why that's true. So when we're talking about volume per volume, the only thing I want to say in this case, so if we had a 12% volume per volume, okay, alcohol solution or wine, what that means is that 12 milliliters, there's 12 milliliters of ethanol in 100 mils of, let's just say, the wine, okay, or the solution. That's what percent volume by volume means, okay? So another interesting one is parts per million. And this is, it looks very different than grams per liter or other concentrations, but it's just a convention that people have been using for a long time. So where does it come from? Okay, so 1 part in 1 million. Okay, so what does that mean? If we put this into a unit, a mass unit, it would be 1 milligram in 1,000 milligrams. And if you go back to our one of the first slides where we're talking about metric conversions, 1 million milligrams actually equals 1 kilogram. Okay? And we also know that water, okay, for a water solution, the density equals 1 kilogram per liter. Okay, which is to say that 1 kilogram equals 1 liter in terms of a water solution. So this 1 kilogram is the same as saying 1 liter. So then we move down, and this all means that 1 milligram in 1 liter of water. So that's what a part per million is. 1 ppm equals 1 milligram per liter. And this has to be a water-based solution. Okay, but wine and juice are both water-based, so it works. Okay, so again, this is a handy one to maybe write out somewhere and stick it to that bulletin board so that you remember that 1 ppm is this exact same as talking about 1 milligram per liter. Okay, so temperature, I noted at the very beginning that temperature is an important one to know what unit you are dealing with. And because of that, you might want to know how to convert in between. And so the way I just want to explain a little bit about temperature, if we look at the point between freezing and boiling, okay, on a scale. If we are talking about degrees Celsius, we know that freezing is 0. Okay, and boiling is going to be at 100. So when we are talking about degrees Celsius, there are nice lineations that we can make, and there would be 100 of these, okay, marks that we would make between freezing and boiling. Okay, so I'm going to get rid of these marks. But when we get down to degrees Fahrenheit is an interesting scale, and the freezing point is 32, okay, and the boiling point is 212. So there are actually 180 tick marks that we would need to make. So they would be much closer spaced together than the degrees Celsius. Okay, does that make sense? The numbers change at a faster rate for degrees Fahrenheit. So anyway, if you want to convert between degrees Fahrenheit and degrees Celsius, this is the equation. Okay, the temperature in degrees Fahrenheit equals the temperature in degrees Celsius times 9/5 plus 32. Okay, make sure that you understand that the order of operations is important. So let's do a couple of quick little examples here. So if the temperature is 30 degrees C, okay, what is it in degrees Fahrenheit? Okay, so let's substitute our 30 degrees C in here, multiply by 9/5 plus 32. Okay, so we're going to do our multiplication first and then our addition. When you compute this all out, you are going to get 86. Okay, so a temperature of 30 degrees C is a temperature of 86 degrees Fahrenheit. So let's do the flip side. What is the temperature in degrees Celsius when we know that the temperature is 30 degrees Fahrenheit? So I'm going to start off with 30 degrees Fahrenheit equals temperature, degrees C times 9/5 plus 32. I'm going to do this math out a little bit so you can see how this works. 30 minus 32, that's going to give me a negative number. Okay, multiply by 5/9 equals the temperature in degrees C. And so when you compute that out, I get a negative number, and that's okay, 1.1. Okay, and that makes sense, right? We know that 30 degrees Fahrenheit is just below freezing. The freezing point of water is 0, so it's going to be a negative number. And so you can see there's a big difference between these two scales. So know which temperature scale you are using at your winery and what someone else is talking in when you are having a discussion. Okay, so US standard units to metric units. This is really important here in the US because there's a mixture of units that people like to use. Personally, I like metric units because I think that they convert nicely between each other. And I also grew up in Canada where we learned metric units, but a lot of people still like to use US standard units. And that's fine as long as you know that you do need to convert between some of these numbers that you may find on your package or in a textbook, or, you know, if you're making any or doing any processes in your winemaking. So the best way to teach this is with an example. So we're going to look at let's say we have a 5-pound addition that we need to make to our wine, and our scale can only read kilograms. Okay, so we need to figure out. So the important thing to know here is our conversion factors. And these are easily accessible on the internet, but I do think that it would be handy to type these out or write these out and put them on that bulletin board for easy access. Okay, so 1 pound equals 0.454 kilograms or 454 grams. Okay, so depending what you need. And then the other one to note is that 1 kilogram equals 2.2 pounds. I'm going to do the calculation using both of these, and you can see that you really only need to use one. Okay, you're going to get the same answer. So let's jump into our calculation. Okay, so kilograms. So we start off with our 5 pounds here, and we know we want to end up with kilograms. We're going to have pounds here on the bottom so that we can cancel those units out. We look over here and we know that 1 pound, okay, equals 0.454 kilograms. That's how we set that up. That's how we use that conversion factor. We compute this out and we're going to get 2.27 kilograms. And if you say to me, but Erin, I looked it up and 1 kilogram equals 2.2 pounds, I'm going to get a different answer. No, you're not. Let me show you why. So let's set this up again. Kilograms, we have our 5 pounds. We know we want kilograms, and we need pounds on the bottom there. Now, I know that 1 kilogram equals 2.2 pounds. Okay? I compute this out. Okay? Remember, we're going to cancel our units and be left with kilograms. And I'm going to end up with 2.27 kilograms. So these two conversion factors that are up here in the red box are identical. Okay? 1 pound equals 0.454 kilograms is the same as, it's the reciprocal essentially of 1 kilogram equals 2.2 pounds. So it doesn't matter which one you use. Okay? So if you find a value that is different than what you were expecting, make sure you set up your calculation correctly, and you should be fine. Let's do one more example of US standard units to metric units. And in this example, we're going to use 2 units that we're going to convert. So on a package, you may see 2 pounds per gallon. I think yeast actually, it might be 2 pounds per 1,000 gallons actually. But in this case, we're just going to say 2 pounds per gallon. And we want to convert it into grams per liter because that's what we're used to working in. And so we know our conversion factors over here. We've got 1 pound equals 454 grams. Okay, and 1 gallon equals 3.78 liters. Okay, so how are we going to set this up? So we know we want grams per liter. And we are starting off with 2 pounds per gallon. Per 1 gallon. That's how I like to set that up. Okay, 2 pounds for every 1 gallon. And now I'm just going to write out my conversion factors. So the first one we're going to take care of is pounds. So I know I'm going to want pounds on the bottom here so that the 2 units cancel. And I'm going to need grams up top. Okay, so 1 pound equals 454 grams. Okay, that looks good. And then the next one I'm going to take care of is the volume. You can do this in 2 steps in your calculation, but it's not necessary. As long as you set up each one individually in your calculation line here, you should be fine. So in this case, I want gallons on the top because I want to get rid of that. And I actually want liters on the bottom in my final unit. So we know that 1 gallon equals 3.78 liters. Okay. We will just make sure that our units, okay, pounds and pounds can cancel, gallons and gallons can cancel. We're going to be left with grams per liter. So that should be good. We compute this out, and we are going to get a value of 240.2 grams per liter. Okay, so you really need to know your conversion factors, and that's why I suggest writing these out, having them somewhere handy that you can access them quickly. Okay, so in summary, I just wanted to present a couple of the things that we talked about in this video. So starting off with the metric conversions. So 1 kilogram equals 1,000 grams. 1 gram equals 1,000 milligrams. Those are conversion factors, just like we did at the end, but some good ones to that you can either remember or write them out on a handy cheat sheet. ppm, or parts per million, is the exact same thing as talking in milligrams per liter if you're talking about a water solution. Okay, so that's a good one to know and understand because ppm gets used a lot in wine. The conversion between degrees Fahrenheit and degrees Celsius, the equation is presented here, and so that's, make sure, especially with temperature, that you understand which unit you are talking about. And then lastly, at the bottom here, we've got a couple of unit conversions between US standard units and metric units that are important, especially here in the US. You'll see both of these units on many different products, and so it's good to understand how to convert in between these two. So thanks for watching this wine math video. If you have any questions regarding the math or the general wine topic covered, feel free to reach out to us at wine@iastate.edu. Check out the other wine math videos to improve your math skills in the cellar. Cheers!